Alrighty, so today what we're going to be talking about is something called row operations. And what these are another strategy to solving with matrices. Okay, so what we're going to learn today is getting us ready to learn how to solve systems tomorrow with another matrix operation. Okay, now what we learned last week does not go away. You can still solve matrices always by using A inverse times B, like we did last week. I'm just going to be showing you another strategy for how to get there, okay? Now, in order to set up that strategy, we have to learn something called, excuse me, we have to learn about some things called row operations, okay? So row operations basically are anything we want to do to a row on a matrix. We can multiply it by a value. We can add it to another row and replace rows. And this is the how, okay? Tomorrow we're going to be talking about why we would want to do this, okay? So what you're going to do is you're going to start by looking at your system here. And we're going to think. Sorry, I'm using this new system. We'll see if it works. And we're going to think, okay, are all of our variables all nice and lined up, ready to go into our matrix? No, what's messed up? Yeah, this z equation. So I need to rewrite this in order, x, y, z, and then my constant. So we have no x's, so 0x. And then minus 1y plus z equals 3. Everyone okay with what I'm doing there? Okay? So now, take your top row and write it into your, this is called an augmented matrix, and I'll show you what that means. So start by writing this top row in. Take your coefficients. So that would be 1, 1, 1. And then I want you to draw in like a little light drawn in line or a dotted line that goes down through your matrix. Okay, and your constant, okay, your 10 over here is going to go in right here. All right, let me show you again. Let's do it with the next row. So our coefficients are 2, 1, 1, and what's our constant? 12. Okay, then take our rearranged one down here. So 0, -1, 1, and we would put 3. All right, now the operation we are being told to do is to take R2, so take the second row, and add it to the first row. And the answer we get, we're going to put it in place of row 2. Okay? Not too hard. Let's see what that means. We are going to keep row 1 the same because nothing is being plugged in for row 1. So go ahead and just recopy row 1. So 1, 1, 1, 10. The second row is going to become row 2 plus row 1. So you're going to add each element. So 2 plus 1 is 3. 1 plus 1 is 2. 1 plus 1 is 2. And 10 plus 12 is 22. Are we changing anything about row 3? Nope. So just copy it back down.
So you added, oh.
Go ahead. You got it? Okay. It's not super hard. Okay? It's real straightforward. We're just kind of practicing something that's going to make a little more sense tomorrow. Okay? All right. Let's go to number 2. First, do we need to rewrite anything? The second equation. How should I rewrite this second equation? Okay, so -x plus 0y plus z equals -8. All right. So now let's fill it in. We've got 2, -1, -3. I didn't save myself very much room, so I'm going to have to go over a little bit. Sorry. 0. Next row, -1, 0, 1, -8, 1, -4, -1, 3. Everyone okay with where I'm getting those numbers? Okay, cool. The operations it's telling me to do are to take R2, so row 2 minus row 3, and where am I going to put my answer? Or sorry, plus, I apologize, plus row 3, and where am I going to put my answer? Row 2. So is row 1 going to change at all? No, so go ahead and recopy row 1 down. All right, row 2 is going to become the sum of row 2 and row 3. So -1 plus 1 gives me 0. 0 plus -4, -4. -1 plus -1, 0. And 8 plus -3, -5. Does anything change about row 3? Nope. So copy it on down. Because it's 3 plus -8, which is -5. So 1, -4, -1, 3. What questions do you have? Okay, give number 3 a try, please. When you're done, check it in with the people at your table and see how you did. Then you can check your work up here. How we do? Pretty good? All right, we're going to skip 4 then, if that's okay. And go on to 5. Okay, start by filling out the augmented matrix on number 5, meaning fill in your coefficients and your constants. Everyone okay filling in that top row? Or sorry, that first matrix. Okay, so look here at what it's asking us to do. It's asking us to take 2 times row 1 and add that to row 2. So 2 times row 1 and add it to row 2. And where are we going to put our answer? In row 1. Okay, so I'm going to do this 2 times row 1 part first. Okay, and I'm just going to kind of jot it out to the side here. You can kind of jot it wherever you have space. So if I double row 1, that would give me 2, 2, negative 8, 24. Would you guys agree with that? Okay. Now I'm going to take that and I'm going to add it to row 2, my original row 2, and where am I going to put my answer? In row 1. Okay, so 2 plus negative 2, 0. 2 plus 3. Negative 8 plus negative 1. And 24 plus negative 5. 19. Does anything else change? Nope, so just recopy them over. Yes. I would, so you can visualize it, so you know what you're doing. Yeah, I would draw in that little line just to keep them separate in your brain. All right, let's go to number 6. All right, so go ahead and fill out your matrix, your augmented matrix. So negative 1, 1, negative 1, 8, 2, negative 3, 4, 24, negative 3, negative 1 half, negative 1, negative 10. Okay, he wants us to do row 2 minus twice row 1. So what I'm going to do is I'm going to take a sec and I'm going to go ahead and double row 1. So, and write it kind of wherever you've got a little bit of space. So minus 2, 2, minus 2, 16. Yes. Okay, so the question was, does this negative distribute? Meaning, are you multiplying everything by negative 2 or positive 2? So you can think of it 2 different ways. You can multiply all of row 1 by negative 2 and then add row 2 and row 1. Row 2 and negative 2 times row 1. Or you can just multiply the top row by a positive 2 and subtract. Okay? Does that make sense? I think that's the easier one, so you don't have to remember. You're just remembering one time to do it.
Okay, so the negative sign.
Think of it as you're subtracting twice times R1. Okay? All right, so start with row 2 and subtract this double R1. So 2 times negative 2 gives me, or sorry, not times. 2 minus negative 2 gives me positive 4. Negative 3 minus 2, negative 5. 4 minus negative 2, 6. And 24 minus 16, 8. Does anything change in the other 2 rows? Nope, so just copy them down. Okay, I would like for you to do number 7 on your own, please. All right, so let's read what we got. go ahead and give your answer. Let's start with the top row. What's the top row going to be?
1, 2, 1, 5.
Good. 1, 2, 1, 5. Second row. Great. Third row. Great. Okay, so the question at the bottom says, are you able to now solve this system? This original system over here at the front of the page. X plus 2y plus z equals 5, all that. So I hear a yes. Where is it coming from? Yes. Why? Yeah. See this bottom row right here? Look what we've created. 0x plus 0y plus 1z equals 4. So what does that tell us? Yeah. We know now that z equals 4, which would that let us keep going to solve the system?
Yes.
Yeah. This is the whole purpose of what I'm teaching you today. Is so we can keep applying these operations so that we can end up with situations like that where we can substitute it. Okay? That's what we're going to be doing tomorrow, is learning how they all go together. Yeah, Isaac? Yeah, I'm going to show you it tomorrow. I need you to understand kind of how it works and what to do with it. But yes, you can decide after you learn tomorrow which calculator method you like better. Okay, Ron?
How do we know what rows to add or subtract like?
So that's what we'll talk about tomorrow. It comes with a lot of practice. We're not going to do a ton by hand. We're going to let our calculator do it. But we're going to be, I want us to understand at least what the calculator is doing before we use it, just like we did yesterday or last week. Okay? Any other questions? Okay, so you have lots of time to get started on your homework. You should finish it.